Well, friends, welcome back. This is Tom in the Rabbit Hole, and today we're going to wrap up the Hobbing Machine Mk2 turntable project with a video about making these kind of cool little micrometer adjusters for the mesh and backlash of this system. I hope you enjoy it. Well, this is what we're going to make. I need two of these, one for each end of the machine. And this is definitely squarely in the overkill department, but trying to adjust the lash of the worm gear mesh with a brass hammer seems a little crude. And this is probably over the top in the other direction, but what I'm going to do is make a couple of micrometer barrels. So this is going to be steel or aluminum, I haven't decided. I'm going to make a steel micrometer spool, 40 threads per inch, which gives me 25 thou per revolution, which just happens to be the same as kind of a standard manual micrometer. And then I'm going to index this in thousandths at an inch. That gives me a reasonable separation on the marks. And I'll do that on the vertical mill. This diameter right there above the recess, that's going to fit a mating slot on the bearing carrier. And this whole assembly is going to kind of wrap around the end of the bearing carrier like that. And I should be able to, with minimal backlash, hopefully, move this in and out in fairly fine increments. Probably even a fraction of a thou if I wanted to go so far as to put a vernier scale on it, which I'm not quite there yet on that one. Anyway, so I'm going to start by making these spin. Okay, here we go. I did this bit off camera, but I made that's a 40 thread per inch threaded hole in steel. I tried it in aluminum and it worked so well, I thought, well, what the hell. It actually came out pretty good. I found a drill bit that was within a couple thousandths of the right diameter, and that looks like it took pretty well. So I'm going to use this to use my touch feel to try to get the thread on the shaft as close as possible and as smooth and tight. That's the main requirement. So we'll see how that goes. One, 8, 2, 8. Zero. About 175. Final level. Let's just chip slide here. Throwing sparks there. All right, back over.
5494. But make that 2 times over here. That will do. Okay, now I need about 17 thread, so 4, 5.
This is without a doubt the finest thread I've ever cut. It's only 17.7 thou deep. Sorry, not 17.7. It's 17.7 at the compound angle. So it's less than that, 15 and a half thou deep.
Let's try and see. Ooh. That's going on. It's friction, but not bad. That's pretty good. There's almost chips in there. I've not seen it. Just look at it. Oh, that's nice. Okay, just a little bit.
Well, off camera, I made a second barrel or a spindle, whatever part that is, I guess. And those two look pretty much alike dimensionally. I also roughed out a couple of blocks of steel like that, which will form the body of the micrometer adjustment system. And once I get that all worked out, I'm going to set up to scribe and number the barrels here. 25 thou per revolution. That ought to be pretty straightforward, but you know, I'm always finding new ways to screw things up. So over on the Bridgeport-like machine, I'm setting up to put the tap hole for the half 40 thread per inch hole, threaded hole, and then I also have to put a counter bore to accept about 3/8 of an inch of that barrel that goes down inside. And then there'll be an index on the face of this somehow that I haven't quite worked out yet, but I'll figure it out once I go. Anyway, that's what I'm up to. Well, here's what that looks like. Got that little diameter there that's going to catch a slot on the bearing housing, bearing support, and then this will adjust back and forth. That's full out, so it goes about 200 thou this way for full in. $25 thou per revolution. Anyway, so far so good. Well, that's the right-hand adjuster. I need to put the scale on the barrel there. This is the left-hand adjuster. These are pretty much the same except for the mounting. And tomorrow, those will be mounted on the turntable, and the turntable will be done. Yay. Well, this right here is quite a bit of diddling around to go for 2 tapped holes, but that's what I'm doing right there, and 2 more on the other side, and that's how this all goes together. Okay, it's time for the test fit. The only machining left to do is the markings on the barrel. Well, that's going to be a whole different setup. Those look like they're going in. little more room there. There we go. It's moving. That's full travel one way. Evidently. A little stiff there. I think this piece is getting cocked a little bit, but I think that's pretty good. I have to tell you, I've always enjoyed making dials. In a lot of ways, it seems like the most boring work in the world, but it's 500 exacting and fun for the long marks. Okay, I'm going to try to assemble this. This should be the final assembly process. We'll see. But I'm going to try to assemble this real time. Starting with getting this one the right way. Well, for as shiny as this project is, there really aren't a lot of parts to it, so it only takes a few minutes to put it together. Tweaking the adjustment and all of that jazz. So I thought I'd speed this up. This video is getting pretty long, so you might hear chipmunks in the background. I'm not sure. that's pretty close to 0. That's close enough for this iteration anyway. So I'm going to lock it down and put the last part on. That feels good. That feels outstanding. That's better than it was before. So I'm delighted to report that the Micrometer adjustment system is superior to the brass mallet that I was using before. So it may be that just all my mistakes canceled out, but it's nice to have a fine adjustment on something as kind of finicky as that 1-gear mesh. So this piece is done. This sub-assembly is done. Oh, the last piece. Well, saved in some ways the best for last. This is the golden dipstick. So that one hole there is going to be the oil fill and drain if I needed to drain it. But I also have a golden dipstick to tell me how much oil is left. And that, friends, is that. This project is done. My next video, I'll introduce you to the next phase of this endeavor, which is going to be working on the feed system. So now that this is done, there's a drive gear and shaft that go right down the middle here and bolt to the turntable. And that's going to be the drive gear that drives the Z-axis, the Z-axis, on this hobbing machine. And the gear train that does that is going to be sandwiched in underneath this turntable, between the turntable and the lower saddle of the machine. I've got it pretty well worked out, I think. There's probably still a few details to attend to, but now that this is done, I can move on to that and start thinking about that a little more deeply. So what I'm going to do is I'm going to move this over to the machine. I'm going to fill it with oil, and I'm going to run it in. Well, friends, that brings us to the end of another project or sub-project and the end of another video. I appreciate your interest, I appreciate your watching, and I appreciate your likes, subscriptions if you haven't already subscribed, and your comments or questions down below. Thanks for watching, and I'll see you next time.